morning. I hope that you had a good weekend and have rested and ready to continue our studies. We have 2 weeks of learning. Then after that, we're going to do culminating activity that we finished the semester with it. I don't want you to worry a lot about it. We're going to do it and we're going to enjoy it, and you're not going to find any difficulty doing it. Just stay focused and try to learn everything we are covering now, and you will find that this activity is very easy, and it is just to wrap up everything we have covered. Okay? So for now, we stay focused on what we are learning. Today we are going to learn the vector and parametric equation of a plane. First of all, what's a plane? If I draw this represents a plane, but it doesn't mean that these boundaries, that plane has boundaries. This is just to tell me the level. Like this goes all the way this way, that way, this way, that way. So we draw it like this to represent a plane, but actually it is limitless. So if I am talking about this plane, I mean everything in this level, like going all the way this way, that way, this way, in this level. Okay? This is what we mean by a plane. Okay, now what makes a plane? If we have 3 points, this is enough to identify a plane that contains these 3 points. If we have 2 lines intersecting or parallel lines, this is enough to identify a plane, because there is only one plane that will contain these 2 lines. Okay, if we have we said 3 points, 2 lines, and a line and a point. There is only one plane that will contain a line and this point, which is this plane. Okay, so a point and a line, 2 lines and 3 points. Those make a plane. Now, in order to find a vector or parametric equation of a line, of a plane, we need 2 things. One, a point on the plane. 2 non-collinear direction vectors. So, no matter what is given to you in any question, we need to end up with a point on the plane, a coordinates of 1 point on the plane, and 2 non-collinear direction vector. I mean, what do I mean by non-collinear vector? I cannot say that these are 2 direction vector, because they are scalar multiples. So at the end of the day, those are the same vectors. So I cannot say that those, so scalar multiples are considered 1 direction vectors. So we cannot use 2 non-collinear vectors. It must be 2 vectors that are not collinear. So in order to find the equation of a plane, we need 2 direction vectors, M1 and M2, and we need a point on the plane. Okay? One of you will say, okay, you said that 2 lines are enough to identify a vector. That's true. 2 lines are enough, but not 2 vectors. vectors are not lines. Remember the first day of lines in 2D, I explained to you the difference between lines and vectors. If I say this is a two-direction vector, there is infinite planes that contain these two-direction vectors, because simply any vectors that are parallel to these are the same. So it is not enough information to have two-direction vector. But if I say a plane that has these two-direction vector and pass through this point, it is this plane only. I cannot say this one or that one. So that's why two-direction vector is not enough. A point definitely is not enough, because there is infinite planes that can go through this point. You understand what I mean? Like, there is many planes go through this point. So we need two-direction vector and a point. So let's say that we have point P that has coordinates x sub 0, y sub 0, z sub 0, and accordingly the vector r that connects the r sub 0, that connects the origin with this point, is called x sub 0, y sub 0, z sub 0. This is the line that connects the point. So there is a plane, there is a point here, this is r sub 0, okay, and then we have m1 and m2. Coordinates of m1 is a1, a2, a3, and coordinates of m2, the second direction vector, is b1, b2, b3. To get any point on the plane, this is the factory that has all the points on the plane. We're going to have r sub 0 plus t, a parameter, times direction vector 1, plus s, another parameter, times direction vector 2. This is the factory that has all the points. This, if I change t and s, I get points on the plane. So this is any point on the plane. This is the vector that connects any point on the plane and the origin, 0, 0, 0. And this is the given point on the plane, x sub 0, y sub 0, z sub 0. This is m1, the first direction vector. This is m2. Those are the parameters. Now, if I want to write this this way, x, y, z, this is the coordinate of any point on the plane. This is the coordinates of the given point on the plane, the point I know, plus t times a1, a2, a3, plus s times b1, b2, b3. Then I can use this to write the parametric equation of the plane. So we're going to do that. So, as we said, r equal r sub 0 plus t times the direction vector 1 plus s times the direction vector 2. This is x, y, z, coordinates of any point on the plane. This is the point we know. And this is the components of the first direction vector. And this is the components of the second direction vector. We can separate those. So I can say x equal x sub 0 plus t a1 plus s b1. Y will equal y sub 0 plus t a2 plus s b2. Z equals z sub 0 plus t a3 plus s b3. And this is the parametric equation. So this is the vector equation. This is the parametric equation. Okay. Now let us have some examples. Example 1. Okay, determine the vector and parametric equation for the plane that contains, they give us the coordinates of 3 points on the plane. Okay, so in this question, they say that we have 3 points, A, B, and C, and I said that this is enough to identify a plane, and we need to find the vector and parametric equation of this plane. In order to do so, as I told you, no matter what is given to us, we need 2 direction vectors and a point. A point, we have no problem. We can use this one, this one, this one, any of them will work. But we don't have direction vector. Yes, we don't, but if we make this a vector and make this a vector, we're going to have 2 direction vectors. So I would say M1 equals vector AB, which is the same thing as B minus A. So I will do B minus A, so I would subtract negative 1 minus negative 1 is 0, 1 minus 3 is negative 2, 0 minus 8 is negative 8. So this is the first direction vector. Our second direction vector is vector AC, which is C minus A. And we can do that, C minus A, so 4 minus negative 1 is 5, 1 minus 3 is negative 2, 1 minus 8 is negative 7. Is this the only thing? No, we can say AB and BC, CA, any 2 direction vector will work. So now we have 2 direction vectors, and we can use any of these points, and we can write the vector equation. So R will be any point, so let's say negative 1, 3, and 8, I used point A, plus T times the coordinates of the first direction vector, plus S times the coordinates of the second direction vector. And this is the vector equation of the plane. Okay, now if I want to write this in parametric form, I will separate those. So x will equal negative 1, 0t plus 5s, y equal 3 minus 2t minus 2s, z equal 8 minus 8t minus 7s. This is the parametric equation of the plane. Okay, now let us say that we want to check if point 14, 1, and 3, check if point 14, 1, and 3 lie on this plane or not. The idea is as follows. We're going to take any 2 coordinates and sub in for x and y and solve for s and t. Right? Then after we solve an s and t, we substitute in the third equation for the values of s and t we get, and see if we get the value of z here. If yes, this point on the plane. If no, it is not on the plane. So I will do that in a second video. See you soon.